So originally this talk was going to be about how to make container monitoring easy. But then I started writing the presentation, I realized there's like a million talks out there, a million blogs on how to do container monitoring, and we were at DockerCon 2 weeks ago and it was all about Prometheus. I think there was like 6 Prometheus talks and things like that. So I figured instead of, because we're not trying to be vendor pitchery in these kind of community meetups, instead of just trying to kind of say how you can make it easy, I'd tell you about how we kind of built ours, because that kind of allows us to kind of dive into the details about how Docker actually works and how you actually get stats and metrics out of Docker, and it's a bit more technical. So that's kind of where I decided to go with this. So just some fun facts about Docker, and this is from our kind of just us surveying our own customer base, looking at all the data in our database. So right now, about 12% of the hosts that we monitor use Docker right now. So that went up from about, I think it literally was probably like 0% about 18 months ago, and it's kind of just zoomed up to 12%, and it's expanding very, very rapidly. The average host runs around 8 containers on our customer environments, which seems to be in line with what other vendors have seen in the market as well. But that also means for us it's created a bit of a problem, because you get 8 times more metrics. Every single container sends back metrics. Now your metrics explode by 8 times. And the other thing as well is the average container runs for about 2 days. We actually have a customer that probably skewed those results a little bit. Their containers spin up around 6 minutes. Like they're literally, I don't know what they're doing, but they're basically spinning up and moving containers around every 6 minutes. And what that basically means is you get a lot of metric churn. So I'll talk about that and how we try to solve that issue later on. So I think most people in the room here are familiar with how Docker works. But essentially it does fundamentally change the way you do monitoring, because in the VM world you can put an agent inside each of your VMs, and all the processes are local. So it's very easy to kind of just monitor a local host process. You don't have any kind of silos or kind of barriers between kind of monitoring that process, getting the metrics out of that process. It's pretty easy. So our solution originally was built for VM monitoring on AWS and cloud services like that. So literally you just put an agent on the server and it would just basically monitor everything. We had auto discovery, it would just pick it all up. But in the container monitoring world, you can't put you shouldn't put an agent into every single container. So you have to monitor containers from the outside, and each container is like a mini host. So it does kind of change the way you kind of monitor things. So like I said, in the VM world, you've kind of got, all processes accessible kind of locally. In a container world, you've got everything kind of siloed, and you need to figure out a way to kind of monitor them from the outside. And what this really means for kind of monitoring different processes is if you've got like something that uses shell commands to kind of pull out metrics, things like Redis and MySQL and things like that, where you're kind of running commands on the thing, you need to be able to basically dynamically Docker exec into that container to run that shell command to get the metrics out, which means that you've got some dynamic kind of configuration there, because now each container is going to have a different ID, and your monitoring solution needs to kind of inject that at runtime. The same for endpoint monitoring. So most popular tools have like an endpoint that you can monitor, like Elasticsearch and Apache, the status pages, all those kind of things. But again, the IP address of that is not localhost. It's now an IP address on a Docker network. So that adds some complexity. You have to inject that at runtime. Again, it makes things more complex. The other thing as well is orchestration. So orchestration makes things even more complex, because essentially it turns your environment into this. You've essentially got Docker images just kind of being spun around, and we look at it like whack-a-mole. You essentially have like, the Kubernetes will go and put like your Jenkins kind of image over here, and then when it wants to load balance, it will shut it down over here and switch it over here. You don't have any stability. You don't have any guarantees that your Docker container is going to be on a certain host at a certain time. And so what that really means is configuration management doesn't really work in that world. You can't write configuration management to hard code your monitoring so that this host is monitoring this container. It has to be about auto discovery. It has to be dynamic. It has to kind of keep up with the rate of change. So in summary, Docker monitoring is pretty hard. It's very dynamic. It needs a lot of smart automation, and so we kind of set out to kind of do a V1 of this about a year ago, and so we had our first Docker monitoring solution for about 12 months. And the first version that we kind of started with is we basically took a tool called cAdvisor, which is pretty popular in the open source world. Does anyone use cAdvisor here? You're familiar with it? So it's a tool from Google. It's pretty cool. It basically auto-discovers all your containers on the host, and essentially allows you to kind of collect metrics out of them automatically. So pretty much the kind of baseline metrics, your CPU, memory, those kind of things per container. It also has, the latest version has like a Prometheus Scraper in there. It also has a generic application scraper. By the way, I built this image just looking at the source code yesterday because they don't really have any good docs on kind of the architecture of cAdvisor and what it does and what it doesn't do. But from what I could figure out, it basically auto-discovers containers, pulls out baseline metrics. It has a Prometheus scraper built in to pull out Prometheus metrics if those containers have Prometheus endpoints. It has a generic application metric scraper, which you can use regexes to pull out from other endpoints like Nginx and things like that. And then basically you've got a web UI that you can log into. You can see all the real-time metrics for that host, using cAdvisor, and also REST APIs so you can pull the metrics out. And then you've got these things called stores where you can basically send them off to different endpoints like Prometheus, StatsD, InfluxDB, Elasticsearch, all those kind of things. So what we basically did for our first version is we had cAdvisor in a container, and we had this kind of rudimentary script that ran every 10 seconds essentially, using the REST API to pull out all the containers. So we'd automatically kind of pull out the containers, new containers would appear, we'd register them into our system, so because we kind of have a way of registering new agents and all that kind of stuff, and then we'd basically just send metrics against all of those. So that kind of worked for a while. For 12 months it was pretty good. The issue we had was it used a lot of memory, so we rolled it out to a big customer. They ended up having to, they rolled it out on DCOS and Mesos, and they basically had to put the memory limit on the containers to about 1.5 gigabytes, otherwise it crashed. And I don't know if that was our script or if that was cAdvisor, but either way, it was using a lot of memory, kept crashing. It was really hard for us to kind of debug when things went wrong. And because it's written in Go and we're not Go, we're kind of Erlang Python developers, it was hard for us to kind of customize and really extend and make it work the way we wanted to. So we kind of went back to the drawing board back in January, and we were like, okay, we're going to replace cAdvisor, so what's the best way to do it? So the first idea we had is our agent has a built-in Prometheus scraper. So we figured, you know what, Prometheus is awesome. Everyone's kind of using it in the open source community. It's becoming pretty much a standard for container monitoring. So how about, if we have, if we basically build a Prometheus scraper that can auto-discover, Prometheus endpoints when a container spins up. You can do a scan of all the ports. Most Prometheus endpoints are between 9,000 and 10,000 in the port range. So you could probably inspect the Docker container. You could see which ports are open, check if they're Prometheus endpoints, they've got Prometheus things to scrape, and then basically our agent can just start automatically scraping that. So you wouldn't have to do much kind of configuration. You just have the agent, and then we just basically use Prometheus exporters to kind of get the metrics out from everything. The issue is, as we found, is most of our customers were trying to get rid of Prometheus. Not because it's not a great tool or whatever, like a lot of people in the community use it. It's just Prometheus doesn't really solve the issue. So our kind of background 3 years ago, why we started Outlyer, was we came from the world of Nagios Graphite StatsD. And in our experience, it took us about 6 months to piece it together with all this custom tooling and custom dashboards, and we just wanted to buy this as a service. That's why we started Outlyer. And when Prometheus came out, it kind of had it was designed for container-based environments, much easier to set up. It's got the Borgmon kind of architecture from Google, so you can kind of scale it out using aggregations and endpoints, all that kind of stuff. And it's built for scale. The thing is the challenge is not now kind of scaling up Prometheus servers from what we've seen from customers that have been using it. That's very easy to do compared to something like Nagios. The issue that we've seen is this setting up all these exporters, configuring all the exporters across large estates takes a lot of time, and you have to kind of build a lot of tooling around that to kind of make it scale, especially when you want to self-service around lots of different teams. So a lot of our initial customers for Docker, they basically didn't want to spend all their time basically configuring Prometheus exporters for all their different services and tools. And there was even some complaints from some of their dev teams. They didn't want to write Prometheus endpoints. They just want to use something like StatsD because Prometheus does use resources. If you've got a very high performance kind of service and you run a Prometheus endpoint, you are running a little web server that has a page that kind of serves those metrics and holds them in memory. So it does use up some resources. Not much, but for high performance environments, it did have a little bit of an impact. So kind of going down that route would have basically defeated the kind of purpose that most of our customers are moving from Prometheus. They're looking for something simpler. So we decided to not go down that route. So the thing about the solution, and I think when you buy a SaaS solution, whether it's us or another one, you're expecting magic. You're expecting it to be simple to install. It just works. That's why you're paying for it. You're not looking to kind of build something, customize it, spend 6 months kind of building it. If you want that, you go to the open source world like Prometheus, Nagios, that kind of stuff. So we figured if we're going to make this magic, if we're going to make this really easy to install and set up and everything like that, we're going to have to own the integration. We can't use cAdvisor, a third party. We can't really use the Prometheus exporters. We're going to have to basically integrate directly into C groups and Docker and basically pull the metrics out and start monitoring at that kind of level and have complete control over the whole experience. So when you get into that world, then how do you get metrics out of Docker? So there's actually 3 ways of getting metrics out of Docker. So Docker has a thing called Pseudo-Files, which I'll talk about in a second. So I'll go through each of these, and basically allows you to pull metrics out using kind of file endpoints. You've got the stats command in Docker, which is pretty basic, to be honest. And then, of course, you've got the Docker Remote API. So with Pseudo-Files, the way those work, if you run a command like this inside your container, you can basically pull it out. But essentially is you can basically mount, sysff C group as a kind of endpoint on your container. And then essentially you can basically read that memory.stat file as though it's a file, it's a pseudo file, which will basically give you a memory dump of all the stats of your memory. You can get one for CPU, you can get one for network, you can get it pretty much for all the key stats you want to get out of the container. So basically, when you start monitoring things this way, your agent essentially looks at, you basically, when you spin up the agent, you basically mount these endpoints into your agent container, and then basically it will just go through all the pseudo files for all the containers and basically just pull out all the stats. So that's pretty much how that kind of works. The other way is you use Docker stats command, where you can basically just type in Docker stats and you'll get all these kind of metrics. But you can see here, it doesn't really give you a lot of metrics. They're kind of very high level. It doesn't give you the detail that you get on this one. This one is like, that's just what you get from memory. There's like lots of metrics there. On this one, you kind of get memory, 2.53%. It doesn't give you a lot of real insight into that. So it's pretty limited, and different versions of Docker have different metrics. Like Docker 1.9 introduced Disco IO metrics, but before that you won't be able to get those from Docker stats. So then the other way, which gives you a lot of metrics, just like with Pseudo-Files, is the Docker Remote API. So you can basically just pull an endpoint on Docker and essentially just pull out JSON objects with all the memory and CPU stats and all that kind of stuff, kind of, in a very easy to kind of, monitor way. So essentially your agent would just then go through and just crawl all the endpoints and basically pull it out via the API. So really, for us, the winner was Pseudo-Files because when you really look at it, first of all, Pseudo-Files, they kind of work for most of the versions of Docker. They're pretty reliable. They've got all the metrics in there. You don't really have these inconsistencies between versions. Docker Remote API was a good alternative because it had lots of, good metrics in it, and it was good reporting. But the problem is different versions of Docker had different versions of the API, and so you basically end up having to kind of customize around that. And also you have to think about networking issues. If someone's SSL, SSL their Docker Remote API, then you're starting to add configuration for SSL certificates and all that kind of stuff. So it becomes more complicated. And then the stats command, well, it was just too basic, so we couldn't use that. So we went with Pseudo-Files. So that kind of solved the first problem. How do you auto-discover containers? How do you get the base metrics out of there, CPU, memory, those kind of things? The next thing is you want to kind of monitor what's going on inside the containers. So like I said before, so we actually use Nagios plugins in our agent. We don't. We use them because they're just open source friendly. We don't want to force everyone to write a proprietary kind of script, and because everyone knows how to write Nagios scripts, or at least most people do. Does everyone here know how to write a Nagios check? I think so. Okay, maybe a couple of people, but yeah, but most people know how to. And if you don't, it's very easy to learn. So we wanted our kind of out-the-box Nagios checks, which work with all the VM world. They can monitor Elasticsearch on a VM, they can monitor MySQL on a VM, all those kind of things, just to work transparently with containers. But as I talked about before, when you run a check from an agent outside the container, or it's running in a different container, you're monitoring basically a mini host from the outside. You have to Docker exec into these to basically run commands, and you also have to kind of insert the IP address if you're kind of monitoring the container through a remote endpoint. So it becomes a harder problem. So the way we kind of solved it was using monkey patching. So all of our kind of plugins out the box actually are written in Python. Python has this cool feature called monkey patching. Essentially allows you to override all the core functions of Python using your own functions and kind of hot patch them at runtime. So what we actually do is we actually took all of our Nagios plugins for all our different services, including customer ones. Like I said in my pitch, our customers write hundreds of custom plugins, and we basically overrid all the core functions that basically are required. So sub-process, being able to if it's running container, we kind of insert Docker exec and run it against a container. If it's not running container, we just run it locally. The thing with the remote thing in Python, we override that. So when you make a remote call, we see if it's running against a container or a non-container. We hot patch it if it's running container to insert the IP address of that container and then make it work transparently. So it actually works really well. We tried it out. It worked on all of our kind of out-the-box plugins, which are about 100 of them, and our customers haven't really complained about it. So it seems to be working for their custom plugins as well. And what we basically do is when the Nagios plugin runs, we kind of insert this extra code at the top of the plugin, and then basically that hot patches everything when it runs, and it just works transparently. So you write a Nagios plugin, it works in a VM environment or a non-VM environment, container environment, transparently. So that was pretty cool. And that solved the problem of how do you monitor stuff inside containers. So the kind of last bit of it is then, well, now you need to make it work with orchestration. So what does that really mean? Because orchestration, there's a bunch of orchestration tools out there. Kubernetes is by far the most popular from what we've seen. Mesos is a distant second, but still pretty popular. Docker Swarm's starting to appear lots more, and I think probably could become the second one. And then, of course, you've got Amazon ECS and Google Container Engine. So in this world, how do you kind of, what does orchestration mean for your monitoring? How does it actually change the way you monitor things using, when you've got orchestration in the mix? And I think it really comes down to this whole analogy of services and containers. Services are pets. You care at the service level, what's happening across the entire service. You don't really care about individual containers. They're just cattle, you dispose them. If one of your containers fails, you just dispose it, spin up another one. And that's pretty much how these orchestrators work. They, if you take Kubernetes as an example, essentially you have your master node that controls all your minions, your minion nodes. And you have these concepts called pods. So pods is, your kind of miniature, your basic unit of configuration where it can be a bunch of containers configured. So your WordPress could be MySQL and a WordPress container together in a pod. And you deploy those out and you'd replicate those, so if you need to load balance, you could have 5 WordPress kind of pods. And you have another thing called a service, which is for load balancing across different pods. So you have all these kind of different concepts, and every kind of orchestration tool has different concepts. So Kubernetes talks about pods and minions and all that kind of stuff. If you go into Swarm, they have their own terminology and all that kind of stuff. So really the only way to kind of make monitoring work with containers is essentially by taking dimensional labels. And what I mean with dimensional labels is you basically take, every orchestration tool in Docker itself included has, key value pair labels that are applied to the containers. So essentially what you're essentially doing is you're sucking out all this metadata from the orchestration tool, and you're applying that into your kind of agent, so you can filter and all that kind of stuff. But you're also applying that to the metrics, so that when you go into dashboards and alerts and stuff like that, you can filter on just, give me an alert on something that's in this pod or something that's running this image or service or what have you kind of thing. So this kind of solves a problem of, how do you overlay that kind of view from the orchestration tool into your monitoring tool? It's really just using dimensions and labels, and you apply them to your metrics, you apply them to your agents, and essentially you get a consistent view across your thing. And that's kind of what we built as well, using our kind of host view, where you can basically slice and dice by different dimensions and group things together. So this is grouped by services and so forth. So that kind of solves the other thing. So that basically gets you your basic monitoring now. You've got monitoring of the containers. You've got monitoring of the apps running inside the containers. You've now got a way to kind of view those containers across across the same view as you would have in your orchestration tool. The problem that actually turns out was actually becoming a big problem for us, and we're still actually working on it because we have some pretty big customers, is constantly growing indexes from metrics churn. So Docker, like I mentioned before, like the average Docker container runs, runs for about 2 days. Every single time a new Docker container is kind of spun down and spins up again, you basically get a new series of metrics, because the host, the unique ID of that kind of that container basically changes. So, and every time you change that dimension, you get a new series of, you get basically a brand new series of dimensions in the index. So we had one customer that before Docker, they were using millions of metrics and that kind of stuff. My customers run pretty big scale. But then as soon as they switched on Docker, it wasn't like they added more metrics or anything like that, but the index grew to about 750 million rows, like, almost a billion actually by the time we we're kind of looking at this issue. So it becomes a big problem, because then when you're scanning a billion rows, we use Postgres as our kind of index. You can imagine, it was becoming a problem when people were trying to search, and we were trying to give a query of what dimensions they could filter on and metrics and stuff like that. It would take a few seconds to load up, and that's not really good for the end user. So the good news is we're not the only ones that have kind of hit this problem, actually. Prometheus actually has hit exactly the same problem, and they wrote a really fantastic blog that I'd recommend all of you guys read. The URL's at the bottom. If you can't read it, these slides will be shared afterwards. But essentially, the way you have to solve this, and the way kind of Prometheus has taken to solving it in their latest version, is you have to start partitioning your indexes by time. So what they basically do in Prometheus, and what we're actually working on right now, is you basically build a mini database index for a time period, like one every hour, or one every few hours, or once every day, depending on your scale. I think we're going for one every hour, and basically what that means is when you do a query across all your metrics, your hundreds of millions of metrics or whatever, instead of that having to scan those 750 million rows because of all that series churn, you get it down to maybe 1 million rows, because essentially the query is only over 2 hours, so you're basically only having to search 2 indexes, whereas before you were searching the entire index, which had everything all the way to the beginning of time. So that we are still working on it, and it's something that's still a work in progress. But the initial results from that are pretty promising, and we're encouraged by the fact that Prometheus has also gone down the same route, and kind of solved that kind of issue. So that is something that you will hit if you start doing lots and lots of containers in production. So really, just the last bit is what's next. So when we look at what people need for Docker monitoring, Docker is really used very much in tandem with microservices, and microservices is used very much in a different way of organizing your teams. So Credit Karma, you talked about how you have all these different teams organized around different services. That for me is microservices. It's about how do you scale agility across your organization as you scale up. Having multiple teams pushing different services to production, and each team owns a cluster of services. But for an operations platform team, that becomes really problematic to kind of manage at scale. So first of all, you need to have everything needs to become a platform that needs to become a service across all your different teams. You don't want every single team looking at different monitoring tools, so you do want to have a single platform where everyone can get a consistent view across everything, and kind of see what's going on. But then for the platform teams themselves, especially when you're using Docker, these developers are just pushing out containers, and building services. You don't really have any visibility or control of that. How do you know what all these services are, what this service is doing, which services are connected to what? So really the next thing that we're going to be working on, and there's already some solutions kind of out there already just for this piece of the problem, and it really is the big thing for I think 2017 is tracing. Basically tracing allows you to kind of start basically, so it's one thing to kind of automatically kind of see what Docker containers are running and automatically discover them and automatically configure plugins to run against them. So that bit, that's a solved problem. That's what we've kind of worked on so far. But the next bit is, you can't have these static hierarchies or these static maps where basically, when you want to kind of go in and see what services are in there, which services are connected to what the dependencies are. If you want to do smart alerting and you want to understand that if your MySQL database goes down here, it's going to impact these 4 services that are kind of connected to it. You need to know how things are connected, and you need to have some visibility. And also, if you follow the Google SRE handbook, you kind of want to work at that kind of more service level, and you kind of want to look at those 4 golden signals of throughput and 500 errors and stuff. And you don't really want to get into the details and all the weeds of the metrics, those millions of metrics you're going to be collecting, until there's actually an issue that you want to try and kind of identify. So We've got some ideas for that. I don't have too much time to talk about it, but essentially, for Docker monitoring, as long as you have auto discovery, you can find all your containers automatically. You have a way of being able to configure plugins to run inside those containers or against those containers in an automated fashion that doesn't require hundreds and hundreds of lines of configuration management. And you add layer on tracing on top, you've probably got what you probably need to monitor a microservices Docker-based solution at scale. And that's kind of what we're working on. So thank you.